Hello. So, hello everyone. A warm warning, a warm evening for everyone. So, let's crack UPSC CSE in English with Unacademy. And my name is Vijay Kumar, and I have 5 years of teaching experience in the civil services, and I have appeared for civil services interview a couple of times, and I have given my mains examination more than couple of times, and every time I have written this preliminary examination I have cracked it with flying colors. Despite of being failure in this examination, I have gained huge amount of experience. That's why I am just in front of you. Like, I have been in this teaching field, just I have gained knowledge on the civil services. Being a failure in this examination, I have guided many aspirants since the last 5 years with geography as optional who cracked this examination already. Clear? So this is one of the marathon sessions which we are going to discuss. In the last lecture we have discussed about geomorphology part 1 lecture. We have seen about basics of geography, we have seen about interior of the earth, we have seen about geomorphic process and all. Clear? So we'll continue up the discussion from there. But before I start up with the discussion of that particular geomorphology, I want to make just one. So I want to make sure that like you won't find any difficulties in this civil services examination. That's why I am making you like I am introducing India's one of the largest learning platform, that is Unacademy. So if you want to crack UPSC CSE just by sitting at your home, you have to crack, like you have to, if you want to crack this UPSC CSE, please try to crack it with Unacademy. Done. So Unacademy, it is one of the India's largest learning platform which is present. So it is one of the largest learning platforms which we have in India. And if you get the subscription done, you can watch the all live lectures and recorded courses from the top educators of India. And how to get the subscription done? It is very simple. Open your Play Store and just drop Unacademy learning app and just try to install the button. So once you install the app, you will be redirected towards the homepage, and once you redirected towards the homepage, just click on UPSC CSE over there, choose your goal as UPSC CSE, and you will be redirected towards the subscription page. And now many aspirants would be getting doubt, like what are the things which they are going to get if they get the subscription done. What are the things which they would be getting once they get the subscription? I'll be saying you these are the 4 major things which you would be getting. Clear? So one is, daily you can attend live classes on this particular platform from top educators of India. So alone in this UPSC CSC category, we have more than 100 plus educators who deal awesome courses which are related to your UPSC syllabus. And these live classes are of highly interactive manner where you can chat with the educator, you can engage in the discussions, you can ask your doubts, and you can also attend answer polls. All these things happen while the class is going on. Clear? So this is a two-way communication. Clear? And if you see, you will find the live test series on the platform and quizzes through which you can evaluate your preparation so that you can accelerate your preparation. Clear? So apart from that, you will find some of the structured courses on this particular platform. Like, it's not like random educators would be coming and dealing these particular subjects. Entire UPSC syllabus would be covered in a structured way. Like, for example, if I am teaching history for you, I'll start up with ancient India, I'll prepare a course structure for it, then I'll deal up with medieval India, then I'll deal up with modern India. Clear? So ancient, medieval, modern, and post India consolidation, all these things happens in a structured way. If I take up with geography, physical geography, Indian geography, world geography, economic geography, so everything would be in a structured pattern which helps you to best prepare along with these particular structured courses. Clear? Apart from that, you will be having unlimited live access. Like, if you see, you can watch these lectures n number of times. like you can watch complete live lectures of all the 100 educators who are present on the platform. Apart from this, if you have missed any live lecture, you can just come and watch the recorded lectures on this particular platform. Clear? So please try to remember this. Clear? Unlimited access. No other option anywhere else you would be finding this unlimited access. This is the best possible way through which you can crack this civil services. Clear? So these are the things which you would be getting once you get the subscription of Unacademy. Done. So like as I've said, we have more than 100 educators on this platform. So we have more than 100 educators, and you can see some of the top educators who are top in the list on this particular platform. You can see Sudarshan Gujjar. Just 1 minute. So you can see Sudarshan Gujjar, you can see Ayush Sanghi, and you can see Prakash Kumar, and also Mrunal Patel. So no description is required for these educators who are one of the best and top educators of India. Clear? So apart from that, you will find a separate column. Once you install the app, you will find a separate column. You can understand how actually the classes would be running on the platform. And on the virtue of the lockdown, which has hit worstly in India, Unacademy has planned 20,000 special classes which are very much free available for you on this particular app. So you can just go onto the app and watch these special classes so that you will understand how actually the two-way communication process happen on this Unacademy platform. Clear? Apart from this, on this particular platform, you can see the upcoming courses which are going to happen, and these upcoming courses will make sure that will make that point clear that you can plan your preparation accordingly. For example, if you are preparing for 2020, you can see exclusive courses which are present on prelims, and if you are preparing for 2021, you can see the batch like Let's Crack UPSC CSE 2021. So these kind of batches are available for you. So in this way, comprehensively, you can plan your preparation on this particular platform. Try to remember this. Clear? So see, these are the subscription prices. Per 1 month it is 7,200, and per 3 month 18,000, and per 6 month it is 28,800, and per 12 month it is 36, and for 24 month it is 43,200. If you see, already it is a discounted price. If you want to get the discount of this 10%, you have to use this code called as VK10. Please do remember this code called as VK10. So if you want to get 10% discount on the subscription prices, please try to use this code called as VK10. Do remember this. And see, these subscription prices are very nominal in nature. They are very nominal instead. Even a 6th or 7th standard kid's home tuition price is more than this. So with this nominal amount, you can crack civil services just by sitting at your home, enjoying all the live and recorded lectures. So continuously travel with Unacademy, you will 100% be benefited on this. So let's move into our particular topics. So yesterday we have discussed with some of the most important topics of like latitudes, longitudes, standard time zone, international dateline, and how to calculate the time. Apart from that, we have discussed about interior of the earth, and along with that we have discussed about the concept of continental drift theory, and we have discussed about the geomorphic process. So all the important aspects we have discussed in the last lecture. In this lecture, we would be seeing some of the theories. In the last lecture, I have also discussed about continental drift theory. In this lecture, we would be moving into some of the most awesome theories which have huge amount of significance in your preliminary examination and as well as in your mains examination. You will 100% be benefited with these particular theories which we are going to discuss now. So if you have any doubts from the earlier lectures, please do, you can drop it in live chat. I'll be seeing it. So hello everyone, good evening everyone. Hello Vishnuvardhan, hello Madhumati, Thalari Srinivas, hello Raviteja, hello Ram Kumar. So welcome to the live lectures. If you find any difficulties, is my voice clear? If you find if there is any disturbance in my voice, you can drop in the live chat. I have just kept the live chat in my mobile, just it is beside me. I can watch that very clearly, the live chat which we are doing. So this will help in communication between us. Clear? Anything, any disturbance, you can drop it in the live chat. Clear? So are there any doubts from the yesterday's lecture? So I hope you don't have any doubts related with yesterday's lecture. So now let's start up with a new concept called as seafloor spreading. Hope everyone remember about continental drift theory. Everyone remember about this particular theory which we have discussed yesterday. This particular continental drift theory which we have discussed. So I'll just remind this particular topic. So it was given by Alfred Wegener, and he was a meteorologist. And this meteorologist never wanted to show or prove about the continental drift theory. Just he wanted to study about the climatic past, so that he can guess what actually happens in the future. So in accordance with that, he has collected some evidences. He has collected different rock structures around the world. He has studied different rock mountain origins, and he have studied about different fossils around the world, and he have studied many other evidences in order to have a keen evidence for the climatic past which has happened. So while he was collecting all these evidences, he came up with some of the interesting things. What were they? The interesting things which Alfred Wegener came across was, Alfred Wegener, when he was trying to collect these evidences, he has came up with two options. One, either continents might have been in the state of permanency, and it is climatic aspects which might have been drifted, or climatic regions might have been in a permanent way, and it was continents which were drifted. In both of these conclusions, Alfred Wegener has chosen the second one, that continents have drifted and climatic regions were permanent. And on that basis of that particular aspect, he has given the theory called as continental drift theory. And continental drift theory, he has said that during the Permian period, we had a single continental landmass called as Pangaea, which was called as supercontinent, and it was surrounded by Panthalassa. Clear? And this was the thing which we have discussed in the last lecture. And the forces, there were some of the forces which were acting on that particular continent. And what were those particular forces? Hope everyone remember about those forces. Those forces include gravitational pull of sun and moon, that is polar fleeing force, and the second one was buoyancy force. So with the two forces, what Alfred Wegener said was, the Pangaea was broken into two land masses. One was called as Laurasia and one was called as Gondwana land. So these things we have discussed, and we have also discussed about the evidences which Alfred Wegener has submitted in lieu of this particular theory. But criticism has however come on the basis of evidences which he has given, and also on the basis of the reasons which he has given. Despite this theory being an utter flop failure, this theory has provided, this particular theory has given huge amount of basic platform for the upcoming theories to be developed. And some of the theories which got developed in such a kind, they are seafloor spreading concept, and also that is plate tectonics concept. So today's discussion would be mostly upon the seafloor spreading concept, and as well as plate tectonics theory, and also on mountain building process, types of mountains and how they have origin and all. Clear? So if you see, to understand the concept of seafloor spreading, see, name itself suggests seafloor spreading. It is nothing but there is an increase of seafloor spreading. So we must understand some basic concepts of seafloor spreading. What are the basic concepts of seafloor spreading? They are convectional current theory and also paleomagnetism. Convectional current theory, it was given by Arthur Holmes. So he was the person who have given this theory, and when this theory was given, many questions were answered with this particular theory alone. So like according to the Alfred Wegener, the reasons which were responsible for the drift were the gravitational pull of sun and moon along with the buoyancy force, but it was not actual reason why the continents got drifted. It is the convectional current which is present in the interior of the Earth's surface, that is responsible for the movement of this particular continents or so-called plates. These things we are going to discuss in this particular lecture. Clear? So, and if you see, what is convectional current theory? So I'll give you a basic understanding of this convectional current theory. Hope everyone know about these two key terms called as lithosphere and asthenosphere. So yesterday I have said that lithosphere is a body which comprises of complete crust, including oceanic crust and continental crust, and also the upper portions of the mantle. It includes in the lithospheric portion. And this lithosphere is not a continuous body, rather it is broken like an eggshell, and one such shell is called as a segmental plate-like structure. This we have discussed yesterday, right, while we were discussing the mechanical differentiation. And I have also quoted a point. What was that point which I have quoted is, these lithospheric so-called different segments or so-called plates, they are floating on this particular asthenosphere. And this asthenosphere which is present, that is nothing but the mantle portion which mostly have the magma structure. Clear? And this lithospheric solid crustal structure which is broken in different plate manner, it is floating on this asthenospheric body. This point we have discussed yesterday, right? And if you see, there is something which happens in asthenosphere. So because of maximum heat and maximum pressure conditions, because as we move deep into the interior of the Earth's surface, for every 32 meter we would be having an increase of 1 degree centigrade. So in that regard, moving into deeper areas post the crustal regions in the mantle locations, we would be having huge amount of hot semi-molten state called as magma. And this magma under heat and pressure conditions, generally it doesn't stay in a constant manner. Rather, this particular magma would be moving. In general, what happens is, to release the heat and to release the pressure onto the Earth's surface, this magma every time tends to push itself upwards onto the crustal surface. You can see the magma is being pushed towards the continental crustal surface. And this particular magma which is being pushed to the continental surface, this magma would be moving in a particular cellular structure manner. And this cellular structure which has been developed here, it is called as convectional cell. Is this clear? It is called as convectional cell. And this particular convectional cell which we have, that is the reason, that is responsible for the movements of continents. Please do remember this particular point, which is highly important. And this convectional current theory is most important basic thing which will give many answers related with the plate tectonics theory and seafloor spreading. Got this point? See, I'll explain deeper about this convectional current theory. This convectional current cell which is present, that have different limbs associated with it. So one, you can see this particular limb which is moving towards the crustal area, it is called as ascending limb. And one particular limb which is moving away from this particular ascending limb, just beside it, it would be called as diverging limb. So we have 4 limbs associated with this. Please do remember them. So ascending limb, second one is diverging limb, and the third one, if you see, the descending limb, and the next one, if you could see, the converging limb. Clear? In this regard, we have 4 limbs associated with this particular convectional current. One is ascending limb, one is diverging limb, one is descending limb, and one is converging limb. And as of now, there is a particular thing which we have to make a note of. Like, we have to understand what actually happens at this ascending limb, diverging limb, descending limb, and converging limb. I'll give some of the notable points. Please do remember them. What are those notable points which you have to remember is, wherever we have ascending limbs beneath the crust, there are chances that the breakage of crust happens over there. And this particular ascending limb might be underneath the oceanic crust, and it might be underneath the continental crust as well. But those ascending limbs which are present under the oceanic crust, they can break the oceanic crust very easily. The reason behind it is the oceanic crust is very thin in nature while compared to the continental crust. It's not like the continental crust doesn't break, but it is the oceanic crust which would be breaking very easily. So when we would be having breaking of this oceanic crust, we would be having the magma which is coming out. And that is the basic idea through which we should understand about the concept of seafloor spreading. Is this clear for everyone? So I'll share you the details of ascending, diverging and descending and converging limbs further. So like if you see how actually the convectional current would be raised, please try to watch this figure. Just place a bowl and drop water into it and place two wood blocks, one attached to each other. What happens? Please put on the stove, and once the water starts boiling, what happens? The wood blocks tend to move. Why? Because of the convectional current which has been developed. So this convectional current makes the wood block to move away from each other. Is this clear for everyone? So this is the best possible example which I could give. And if you see same pattern, try to take the example of their surface. Here, think these as wooden blocks and think this as the water. And in the mantle region, the magma which is present that has high temperature, hence the convectional current is developed. Hence we would be having movement of these wood blocks away from each other. Is this clear? Hope you have got a better idea. Yes, you will come to know, Naidu sir. You will come to know within the upcoming slides. Is this picturization clear? Hope you have got a greater idea of how actually the convectional current makes the continents to move. Clear? So now, if you see, we'll move and enter into the concept of seafloor spreading. Convectional current theory is the soul of this particular seafloor spreading theory. Arthur Holmes in 1930s discussed the possibility of convectional currents in the mantle, and these currents are generated due to radioactive elements causing thermal differences in the mantle. According to this theory, the intense heat generated by the radioactive substances in the mantle within a depth of 100 to 2900 kilometers below the Earth's surface seeks a path to escape and give rise to formation of convectional currents in the mantle. So please try to remember these particular statements. And if you see, whenever we have the limbs which are raising, those raising limbs of these oceanic currents meet and oceanic ridges are formed on the seafloor due to the divergence of the lithospheric plates. There we have seen different aspects, like one we have seen ascending, one diverging, one descending and one converging. So at the raising limbs of these currents meet, oceanic ridges would be formed. We will see in the upcoming slides how the oceanic ridges would be formed. And if you see, due to the formation of these oceanic ridges, the seafloor generally spreads. And the diverging limb which is present just adjacent to that of ascending limb, that makes the ridges to move away from the central zone where the volcanism actually is happening. And this diverging limb reaches until that extends, and wherever we find this descending limb in that particular zone, descending limb, this particular crust, so-called oceanic crust, tends to subduct in to the mantle again, and again it would be converted as magma and again flows as convectional current and again comes as ascending limb, and again volcanic magma tends to come out. In this way, this is completely a cyclical process. The movement of lithospheric plates is caused by the movement of magma in the mantle. Rather, the explanation which was given by Alfred Wegener, the gravitational pull of sun and moon, the buoyancy force, they were the foolish arguments or the foolish reasons which were given by Alfred Wegener. So, convectional current is the major reason why we have actually the movement of lithospheric plates. And next we have to understand about paleomagnetism, so that we will understand the seafloor spreading concept and plate tectonics theory in more deep manner. See, what is paleomagnetism? The magnetism the magnetic characteristics or the magnetic properties which have been left out in the older rocks, which were recorded in the older rocks. That is called as paleomagnetism. The left out magnetic properties in the older rocks which were created because of the volcanic activities, that particular magnetism is called as paleomagnetism. Please try to understand this particular concept very perfectly, because there might be a question in your mains as well related with paleomagnetism. They will ask you a direct question: what is paleomagnetism, and explain how paleomagnetism helps in understanding the plate tectonics theory. Clear? So if you see, paleomagnetism is study of record of Earth's magnetic field with help of magnetic field recorded in the rocks, in the older rocks, or in the sediments, or in the archaeological materials. We would be having very limited version of magnetic properties which are present, but in the rocks which are formed because of the volcanic magma, we would be having maximum magnetic properties in those. So in general, the rocks which are formed from underwater volcanic activity are mainly basaltic in nature. Please do remember this point. Hope everyone know what is basaltic. So basic lava, it is low in silica content and it would be very rich in iron content, that which makes up the most of the oceanic floor. Those rocks which are available under the water, which are formed because of the volcanic activity, they are mainly basaltic in nature. And these basaltic rocks which are formed, that have basic lava in it, and that basic lava which is present makes up most of the oceanic floor. Clear? And basalt contains magnetic minerals. So the basaltic rock which is present, that generally I'll be showing you how these minerals align themselves in the direction of magnetic field. You would be completely surprised to understand how these particular minerals align themselves in the direction of magnetic field. Because for example, let's say we have a rock, like let's take one particular example. Say this is the geographical North Pole and this is geographical South Pole, and it is hence true that there is no certain condition. Please do remember this statement: there is no certain condition that the geographical north has to correlate and exist same with that of geographical north. Geographical north might be present at any location. It might be this zone, magnetic north and magnetic south, or magnetic north might core portion which is present, that is responsible, that is responsible for the development of Earth's magnetic field. So as the inner core which is present, that is surrounded by the liquidified outer core, the inner core is subjected to movement under the buoyancy impact. Because of the outer core which is maximum having liquid, this inner core tends to move here and there. So that makes, when the inner core tends to rotate, the magnetic north tends to move here and there. And the magnetic north and magnetic south are not permanent in nature. Please try to remember this particular statement which is associated with that. Clear? So magnetic north and magnetic south, it is not true that they have to be present near to the geographical pole of north and south. So for example, let's say if magnetic north is present in this way and magnetic south is present in this way, and the volcanic activity now has happened on the seafloor, and that particular volcanic magma which has come out, that has resulted into formation of basaltic rock, and that basaltic rock instead would be attaining some magnetic properties in it, and that basaltic rock would also have some certain north pole and south pole. Let's assume that this basaltic rock which is present, because of the north pole present in this zone, that basaltic rock has been created in this particular direction. Clear? The formation of basaltic rock has moved in this particular direction. Now let's assume magnetic north has shifted here and magnetic south has shifted here. And what happens to this basaltic rock? It takes an anti-clockwise direction. We would be having movement of this basaltic rock in an anti-clockwise direction, because we had the entire shifting of opposite movements of the polar regions. Magnetic poles which are present, they have completely shifted in opposite direction. So the basaltic rock which is present, that will also shift accordingly. Clear? So in this way, this is one of the concepts which will let you know about the seafloor spreading concept and plate tectonics. Is paleomagnetism which is present, is that responsible for plate tectonic movements? Absolutely, it's 100% true. If you see the logs in the record of which way the magnetic field was positioned at the time, paleomagnetic studies of rocks have demonstrated that orientation of the earth's magnetic field has frequently alternated. So we generally call it as geomagnetic reversal, or we generally call it as polar magnetic reversal. So over the geological time, we had completely seen the frequent alteration of this earth's magnetic field, through which we would be having development of this particular seafloor spreading concept and also plate tectonic. Here I am not saying paleomagnetism is the only reason for seafloor spreading or plate tectonics. It is paleomagnetism along with some other reasons which are responsible for the seafloor spreading and plate tectonics theory to happen. Clear? And if you see, the polarity of earth's magnetic field and magnetic field reversal are thus detectable by studying the rocks of different ages. Clear? So paleomagnetism, which has been created, that led the revival of continental drift hypothesis and its transformation into theory of seafloor spreading and plate tectonics theory. The regions that hold the unique record of its magnetic field lie along the mid-oceanic ridges where the seafloor is spreading. Hence, the Earth's magnetic field which is present, that has a connection with that of this particular seafloor spreading concept. Clear? On studying this paleomagnetic rocks on either side of oceanic ridges, so as I have said, wherever we would be having the ascending limb of the convectional cell, there we would be having formation of oceanic ridge. So there, studying about the paleomagnetic rocks, we have understood one particular statement, that was like, it is found that alternate magnetic rock strips were flipped, so that one strip would be of normal polarity and the next one is reversed in that way. I'll show you the picturization within the upcoming slides. You will be making a note of it. Clear? So like, hence paleomagnetic rocks on the either side of mid-oceanic ridge or submarine ridges provide the most important evidence to the concept of seafloor spreading which has happened. Clear? See, now we have magnetic. So this is the north magnetic pole. Clear? It is normal today, and when it would be reversed, we would be having this particular condition. Clear? So north magnetic pole may have shifting towards the southern pole region, and magnetic south may shift towards the geographical north region. So when there would be shift of this particular magnetic poles, then 100% we would be having shift and dramatic change in the landform development. Hence, geomorphology has huge significance from that of paleomagnetic activities. So until now, the question was not asked on this particular paleomagnetism. There are high chances that questions would be framed on these particular aspects of paleomagnetism. Please try to get ready with these particular concepts. Clear? See, along the mid-oceanic ridges, you can see, you can find alternate strips. See, in the picturization of A, when the magma has came out, the magma has spread out in this way and ridge-like structures were being developed. Ridges are nothing but small hill-like structures which are developed on the oceanic floor because of the eruption of magma at the breakage of the oceanic crust. Clear? And if you see later on, when they have spreaded in different directions. Clear? So you can see the alternate strips of this particular rocks, and when you read about these mid-oceanic ridges, then you will have a huge clarity associated with that. So the oceanic ridges are boundaries where tectonic plates are diverging. So in these locations where the oceanic ridges are formed, at this oceanic ridges boundaries, the tectonic plates are diverging away from each other. So whenever we relate divergent plate boundaries, whenever we see divergent plate boundaries in plate tectonics theory, we will be reading about the same related with the oceanic ridges itself. If you see, The fissure or vent between the plates allowed the magma to rise and harden into a long narrow band of rock on either side of the vent. And this long narrow band of rocks which are developed on the either side of the vent, they are called as ridges. And the rising magma assumes the polarity of Earth's geomagnetic field at the time before it solidifies on the oceanic crust. Clear? And if you see, as the convectional current pulls the oceanic plates apart, clear, as we have discussed, we were having the diverging limbs. As these diverging limbs were pulling the oceanic parts apart, the solidified band of rock moves away from the vent. So at the ridge we had solidified formation of band of rock, and when this convectional current pulls the oceanic plates apart, the solidified band of rock moves away from the vent, and a new band of rock takes its place a few million years later when the magnetic field was reversed. So what generally happens is, now the rock which has been formed and which has moved away, and now the volcanic magma which has come out, now this particular volcanic magma which has come out and created rocks, this rock will take some other polarity region when compared to the rocks which were taken few million years ago. So one particular band of width, every band of rock doesn't experience the same movement or the same direction. Every band will change because the Earth's magnetic field would be completely reversed. Clear? So Earth's magnetic field might alternate itself. They might alter itself anytime. So when a new rock would be created, we would be having changing of that particular rock in different direction. Clear? So this process repeats over and over, giving rise to series of narrow parallel rock bands on either side of ridge and alternating pattern of magnetic strip on the seafloor. Is this clear? So this theory appears to be somewhat difficult for you. If you haven't read some basics related with geomorphology, then only this particular theory appears somewhat difficult, but no need to worry regarding with that. Generally question, if they ask, they will ask with paleomagnetism associated with seafloor spreading. In reverse sense, if you haven't understood the paleomagnetism, you can understand seafloor spreading and plate tectonics very easily. If you haven't understood paleomagnetism as well, you can understand this concept. So after understanding seafloor spreading and plate tectonics, once try to go and see what actually paleomagnetism is. So if you haven't understood now, then at least try to read it and remember it post you read about these particular things. Clear? So shall we move into concept of seafloor spreading? So like earlier we used to think that the sea floor was completely a plane structure, it is completely a flattened structure. Clear? So this particular concept of sea floor spreading has derived many things. Clear? So generally before we did not had submarine usages. So since the last 1 century itself, we have started using these submarines. So with the invention of submarines, we have came across with many things, that the sea surface which is present, that was very rigid in nature, and the topography which is present, that is not having any plane surface as such. That particular topography which is present, that is highly dissected in manner. Clear? And then many questions have raised. The questions were like, continuously we were having movement of magma onto the oceanic crust, and continuously we had development of ridges. So this is common thing. When we would be having the magma which would be raising out, we would be having continuous small chain of mountains which would be raising. But there were some scenarios which could not be answered before the concept of seafloor spreading. And what were the questions which were not answered before the concept of seafloor spreading was, one point is, when we are moving away from the mid-oceanic ridges, we have observed the increase in ages of rocks. This is point number one. Point number two is, like near to the trenches region, we had the dismantling of sea mounts, we had dismantling of guyot-like structures, we had dismantling of some volcanic rock-like structures. And point number three, the rocks whichever might be present on the oceanic floor, they are not older than mid-Mesozoic era. These were the three things which were not answered before the question, before the seafloor spreading concept was derived. So hence this seafloor spreading concept would be giving us gradual understanding of all these things, and it will be giving us all the answers for the questions which were not understood before this. So it was Harry Hess who has proposed the idea of seafloor spreading. So accordingly, when two oceanic plates diverge, tensional stress causes fractures on the oceanic floor to occur in the lithosphere. Hence, when the fracture occurs, the basaltic magma rises from the fractures and cools on the oceanic floor to form a new seafloor. So where we had seen the formation of ridge-like structures, that is nothing but new seafloor or new oceanic floor which has been developed. So if we are continuously having the upwelling of magma, if the magma is raising continuously onto the oceanic floor, hence the seafloor spreads in generally. But if magma is, see, this is a day-to-day scenario which generally happens on the oceanic floor. If you might have read about the volcanism earlier, so this volcanism might have, you might have read about this volcanism in different aspects, like volcanic aspects are most common on the oceanic floors. So these oceanic floors which have the volcanism, those particular oceanic floors would be having continuous volcanism. Hence, it means continuously seafloor has to spread, but it is not spreading as such. Why it is not spreading? These questions would be answered. Clear? So if you see the newly formed seafloor, then gradually moves away from the ridge. Why it is moving gradually away from the ridge? Because you can see the ascending limb, near the ascending limb on the oceanic crust, we are having formation of this mid-oceanic ridges, but adjacent to this we have diverging limb. This diverging limb is making this plate to push away from each other under the tensional stress which has been developed. Hence the ridge would be moving away from each other. Hence what generally happens is the newly formed seafloor at the central portion of the ridge gradually moves away from the ridge, and it takes place, its place is taken by even newer seafloor, and the cycle generally repeats as such. Is this clear? And if you could see, this is the pattern which would be developed. See, these are the fractures which have been developed, and near to the fractures you can see alternate chain of mountainous rocks which are generally observed at this motion. Clear? So these kind of continuous chain of band like structures are developed. If you see, the oceanic floor is diversified in this way, like we would be having continental shelf, continental slope, continental rise, sea mounts, volcanic islands, guyards, and we would be finding mid-oceanic ridges, we would be finding trenches, we would be seeing the abyssal plains. See, you can see the continental rise. This I am not going to discuss as of now. I'll be discussing that in oceanographic marathon session in a deep manner. Clear? So with the time, if you see, the older rocks are spread farther away from the spreading zone. If you see rock number 1 which has been formed, then 2, then 3. So it was the most oldest rock which has been formed. It is the like recent one before it was formed, and it is the newer one. If you see the rocks which are present at the central zone, which are present at the spreading zone, they would be more younger. And as the diverging limb just adjacent to that of ascending limb, it is making the older rocks to push away from the central zone. Hence from the ridge, when we move far away, we would be having increasing of rocks, and this rocks increasing of ages of rocks, and this increase of ages of rocks and this increasing of this rock structure on the oceanic floor is nothing but the concept of seafloor spreading. Clear? So what are the evidences? If you see the nature of oceanic rocks around mid-oceanic ridges, that would be the most important evidences. And also distribution of earthquakes and volcanoes along the mid-oceanic ridges, it would also be an evidence of concept of seafloor spreading which has been developed. Clear? Is this clear? And the rest of the two questions which were not answered, they were also answered by this Harry Hess. So how that was answered was like simply, whenever there would be continuous upwelling of magma, then the oceanic crust has to be increased completely, and also it is the Earth's volume, Earth's crustal volume, which has to increase. But that is not actually happening. Why that is not happening is the amount of crust which is created at this central zone, the same amount of crust is destroyed somewhere else at the subduction zones. And these subduction zones which are present, these subduction zones are present at the trench margins. So near to the trench, the oceanic floor generally subducts. Instead, in a reverse way, if you calculate, near the subduction zone, we would be having development of trench. So the amount of crust which is developed at the mid-oceanic ridges, the same amount of crust is being destroyed near to the trench locations. So second question has been answered. And the third question is, like the oceanic rocks which were present, they were not older than mid-Mesozoic era. So what's the reason behind it? So the reason behind it was like this particular mid-oceanic ridge, when it was formed, that particular oceanic crust which was formed before mid-Mesozoic era, that has already subducted down. That has already, we would be finding the evidence of mid-oceanic ridges. Is this clear? Hence, we would be helping in understanding about the trench locations at the plate tectonics theory, how actually the trench would be developed. We will be seeing in the upcoming theory. Is this clear for everyone? So if everything is clear, hello everyone who have joined to this live session. Please do give a like symbol, that will give a motivation, and you can also drop comments in the comment section. And the doubts which you are having, you can drop it in the live chat session so that I could see them and I could clarify them. Any doubt? Before we start up with plate tectonic theory, I'll just wait for 1 minute. You can cope up with your doubts wherever you. So please give a like symbol. And please also do share this particular video on your social platforms so that it can reach as much as it can. So it can reach every corner of the country. Please do share it. This is the only benefit which you can do. I'm putting all my efforts. So the only thing which you can do is just to share it. Just give a like and just share it, and do subscribe to Let's Crack UPSC CSE English channel. And if you want to crack civil services, just get the subscription of Unacademy, and with nominal prices, just by sitting at your homes with comfortable devices, you can crack civil services. Yes, we have some doubts. Sir, older ridges are already hardened. How it will replace by the newer ones? See here in this, if you see, this is the older ridge which we have, right? See, this is the older ridge. See, ridge number 1 which has been formed, and this ridge would be pushed away from the central zone. Why? Because beneath we have the diverging limb. This diverging limb is pushing the ridge away from the central zone. Hence, we would be having the, and then we would be having again newer ridge formation here. Is this clear? Yes, Raviteja. Sir, is convectional cell theory refers to continental crust? Abhidikshit, can you please drop your doubt once again? About this paleomagnetism again in plate tectonics, I'll take the reference for you on the plate tectonics theory. Shall we? So we'll start up with plate tectonics theory. It is one of the most accepted theories. Clear, many questions would be answered on the basis of this particular plate tectonics theory. Please try to have a huge understanding of this plate tectonics theory. Whenever, anytime UPSC, if they want to give any question from geomorphology, either in preliminary examination or in mains examination, their mind will completely divert towards plate tectonic theory itself. So if any question frames, 99.9% chances are there that the question would be framing from there. So the theories which were already given clear by many of the geographers, like earlier we had theory of continental drift given by Alfred Wegener, convectional current cell theory which was given by Arthur Holmes, and also the theory of seafloor spreading which was given by Harry Hess, the theory of plate tectonics was formulated. Clear? So in 1967, it is Mackenzie and Parker who suggested the theory of plate tectonics, and Morgan has later outlined this theory in 1968. So just whenever you make a note of this plate tectonics theory, so whenever you write about those geographers who are necessary, who have given this theory, try to take the name of Mackenzie, Parker, and Morgan. Otherwise, please leave it off. Don't take Parker is the person who have given plate tectonic. Please don't do that. If you know all the three names, then only quote it. Otherwise, just leave it off. Just say that plate tectonics theory was given during the 1960s and 1970s. Clear? So this can be done. Clear? So this particular plate tectonics, now you have to understand what actually a plate is. Clear? So plate is nothing but, as I've already said, the upper portion of the lithosphere which is present, that is broken like an eggshell, and that lithosphere which is broken like an eggshell, that one segmental structure would be called as plates. And these different lithospheric plates, they are floating on asthenosphere, and as asthenosphere is having continuous movement of this convectional current cell theory, as we have continuous movement of convectional current, we would be having movement of plates in different manner. If you see, we would be having plates which are moving horizontal over asthenosphere as rigid units, and on the basis of its size, if you calculate, lithospheric plates might be divided varying from minor to major plates. I'll show the examples related with it even. And you can also have, on the basis of its origin, if you could see, we may have oceanic plate, like example Pacific. We may have continental plate, that is Eurasian plate, or we may have combination of both continental and oceanic plate. And if I could say this particular statement, it would be 100% true that the entire crustal surface which is present, that is just generally divided as lithospheric plates, and these lithospheric plates make combination of the crustal surface which we have. And these plates might be minor plates or major plates. Simply we can say that minor plates are part of major plates itself, and we can say that these lithospheric plates might be continental plates or oceanic plates, or it might be combination of both. Then, and the movement of these plates are just formed because of convectional currents which are present in the deep mantle, and these movement of plates are the reasons, are the causes for formation of various landforms on the earth's surface. So please try to have a greater grip on plate tectonics theory. Clear? So like if you see, force of the plate movement, as I've said, convectional current, and rate of the plate movement, the Arctic ridge has the slowest rate, and the East Pacific, which is in the South Pacific, would be having the fastest rate. Don't remember this. Clear? Just for your knowledge, I have given this statement. Clear? Position of continents as of now, if you could see, so this is the position of continent according to Alfred Wegener. Clear? These were the position of continents, and we can divide this entire lithosphere, entire crustal surface, into different plate like sections, and these are the major plate tectonics. You can see this. Please do remember this. Once try to open your atlas and sit, better you can understand. Until then, I'll take some doubts which have been given. Govinda Reddy sir, why some convectional cells are moving in anti-clockwise? That depends upon the position of the moment of magma. There is nothing like, you don't have any specific reason for it. Govinda Reddy. Abhidikshit, does convectional cell theory also applicable to continental crust? See, convectional current cell theory is not applicable to continental crust. Rather, convectional current cell theory which is present, that is present in mantle just because we have molten state which is present in that region. Clear? So try to open your atlas. Clear? So in this way, we have some of the major plates like Antarctica plate, which is the most important one. North American plate, South American plate, Pacific plate, Indo-Australian plate, African plate, and Eurasian plate. Clear? In all of this, it is the Pacific plate which have connection with many other plates like North America, South American plate, and Indo-Australian plate as well. So you can see a particular specific chapter of plates in your atlas. So try to visualize them. You can observe these in this section. Clear? See, this entirely specific plate. The picture might not be clear, right? That's why open your atlas and see. Clear? That would be the best possible way. And see, this is North American plate. And this is South American plate. And if you could see, this entirely is African plate. And this entirely is a Eurasian plate. This region is Eurasian plate. And if you see, there are many other smaller plates associated with that. Like if you could see Nasaka plate, Caribbean plate. Clear? So minor plates are nothing but they are part of major plates itself. Just have an understanding of this in that regard. So the entire crustal surface which is present, that is divided on this particular basis. Clear? You can see these particular minor plates, and if they are not present, so hope this is clear for everyone. So is there any disturbance in between? Is this clear for everyone? Shall we move further? Please try to by heart these particular plates, like major plates, minor plates which are present. Please try to by heart them. Done. Now, see, these particular plates which are present, they will have some interaction between themselves. And these particular plates, major geological features like such of fold mountains, block mountains, mid-oceanic ridges, trenches, volcanism, earthquakes, etc., are a direct consequence of interaction between various lithospheric plates. So there are three ways in which the plates interact with each other. Simply, when two plates are coming towards each other, they are convergent plate boundaries. So I'll give a detailed description of this within a few minutes. Like before that, you just have an outline understanding of this. Clear? So if the plates are moving away from each other, they are called as divergent plate boundaries. And if plates which are present, they are moving parallel to each other, but they have the opposite direction in their way, they are called as transform plate boundaries or transverse plate boundaries. So these three plate boundary moments are responsible for various relief feature generations on the earth surface. The earth as of now, if it is present in this zone because of various modifications, it is because of these geomorphological features which have been developed. Clear? You can see these plate boundaries. Clear? Where we have convergent, where we have divergent, you can make a note of this. See here, just 1 minute. So in this zone, like wherever you find this kind of reddish color, dark maroonish color, in those regions it means that we have the convergent plate boundaries. So all along the Pacific belt we have this convergent plate boundary. So along this mid-world belt also we have this convergent plate boundary, and near to the India, near the Himalayan regions, we have this convergent plate boundary. And wherever you had this whitish line, whitish dark mark, like whitish pale color, there in those regions we are experiencing divergent. If you could see all along this zone, all along this zone, see, you could see this as well. all along this zone we have divergent plate boundary and a bit of transform plate boundary also, and a bit of transform plate boundary also. So if you remember this, the rest to 20% is done. Clear? And why it is called a specific ring of fire and what happens when convergent plate boundaries, that we would be discussing. Clear? Simply, divergence or constructive plate boundaries. So when plates move away from each other, when plates move away from each other, they are called as divergent plate boundaries. In this kind of interaction, if you see, the plates diverge. It means they move away from each other. In that scenario, we would be having development of mid-oceanic ridges. The recent one which we have seen near the seafloor spreading process, at the ascending limb, the crust is being broken, the oceanic crust, and adjacent the diverging limb which is present, that diverging limb is making the crust to push away from itself. There we are experiencing this mid-oceanic ridges. So hence mid-oceanic ridges are nothing but they are the resultant of the divergent plate boundary which happens on the Earth's surface. The best example you can quote is mid-Atlantic ridge. In the Atlantic Ocean, if you see, we have an S-shaped mid-Atlantic ridge which is developed. You can see here. See, mid-Atlantic ridge which has been developed almost in an S-shaped structure. So this is nothing but the mid-Atlantic ridge, and these kind of ridges are also common in Pacific Ocean and also common in Indian Ocean. But it is most evident that the exact figure of these ridges can be visualized in the Atlantic Ocean. So please try to see that Atlantic Ocean map. You will 100% visualize this particular ridge. Clear? These particular mid-oceanic ridges, they are formed due to this kind of interaction. So in this region, when divergent plate boundary movement has happened, the basaltic magma has erupted out as we have discussed, and hence when basaltic magma has erupted out, we had formation of ridges, and when we had movement of these plates apart, and that has resulted into concept of seafloor spreading. And if the same divergent force is applied on the continents, this is what, like on the oceanic crustal surface, if the divergent forces would be applied, then we would be having the concept of seafloor spreading. That is 100% true. But if the same thing happens on the continent, what generally happens? We had development of East African Rift Valley. Hope everyone remember about the tensional forces if they are applied on the continental crust. I have said you a statement yesterday related with the faulting and rift valleys. So if tensional forces are applied during the divergent plate boundary movement, it is the tensional force which would be applied, and during this tensional force which is applied, we had the rift valley association which would be developed. It means whenever divergent plate boundary movements are formed on this particular continental boundary, we would be having formation of rift valley on this. And when we have formation of rift valley, if still the divergent movements are applied on this, again that rift valley would be narrower completely, and hence the oceanic water would be entering this margin, and this oceanic water which enters into this margin, this result into formation of a nascent sea-like structure. And the Red Sea, if you could see, that is the best example which has been developed in the Rift Valley portion between the Saudi Arabian plate and the African plate. Once you can open the map of Red Sea, and you can see it is nothing but when two plates are diverging away from each other, the central portion, when it becomes narrower and narrower, when it becomes thinner and thinner, the oceanic waters tend to enter into these narrow rift valleys, resulting into formation of nascent sea developments. Clear? And if you see, before this nascent sea was developed, as I have said, rift valley development has happened, and this rift valley which has been developed, whenever in any region wherever we have the rift valley association, adjacent to that we would be having notion of block mountain. See, this actually is not a mountain. Here we don't find any kind of peak structures, but the adjacent region which has subsided because of the divergent force which was applied, that particular region which has subsided, from that region when you watch this particular elevated region, that appears like mountain. Hence those kind of block mountains which are present, they are resultant of this particular rift valleys. And if you could see on the continents, when divergent plate boundary movements would be occurred, we would be forming development of rift valleys in the initial stages, and if this rift valley is extended, then we would be having development of nascent sea. Nascent sea is nothing but new sea. Red Sea is the example of this. And on the African continent, you can see like East African Rift Valley, which is the most important geomorphological feature formed due to divergence of African and Somali plates. And these divergent edges are sites on the Earth's crust formation, hence the name constructive edge. And the volcanic earth forms are common along such kind of edges. See, whenever we have the formation of Rift Valley, generally we would be experiencing a kind of volcanism in this region, because that particular continental portion has been thinned, and because of the thinness which has been created all along the Rift Valley, there are chances that along these zones we may experience the volcanic eruptions. Clear? And earthquakes are also common along the divergent edges. Is this clear? Venus, sir, does Rift Valley can be transformed into trench? No, absolutely no. Trench is something else. Rift Valley is something else. Both are different from each other. Trenches are associated with convergent plate boundaries. So this is what happens. Once see the picture, you will understand this. So if you could see in this particular section, like first divergent forces are being applied on this particular body, then a development of rift valley has been created, and these adjacent regions, they start appearing like block mountains, this step like terraces which have been formed. Clear? This is a rift valley. And Narmada river in India, such kind which flows in rift valley, and Narmada and Satpura ranges which are present in between, that we have rift valley, and these Satpura and Narmada are block mountains itself. Clear? And then this particular water tends to extend into this body, and hence we would be having development of nascent sea again. A new sea is developed. Example, Red Sea, as I have quoted. And again on the oceanic floor, what happens? Again volcanic eruption, again divergent forces on the oceanic floor, again the volcanic magma tends to come out, again mid-oceanic ridges, again the concept of seafloor spreading. So final resultant should be the seafloor spreading which would be coming out. Next one is convergence or destructive plate boundaries. And now my question is, why divergence plate boundaries are called as constructive plate boundaries? Please answer this question before we move into the next point. Why this divergent plate boundaries are called as destructive, sorry, here the reason behind it is, wherever we have the divergent plate boundaries, there is no destruction of crust at all. Rather, because of volcanic eruption, the magma which is coming out, we are experiencing the construction of crust. Hence they are called as constructive plate boundaries. While we come to this convergence plate boundaries, the convergence plate boundaries are called as destructive. Why? Because we would be having destruction of the oceanic crust. If you see, convergence plate boundaries are those where plates would be coming towards each other, and where we would be having applied compressional force. So in this kind of the plate boundary moments, we would be having two lithospheric plates collide against each other, and the zone of collision may undergo crumpling and folding, and the fold mountains may emerge. Himalayan boundary fault is one such example. Like all these Himalayan ranges are the resultants of convergence plate boundaries itself. And when one of the plates is an oceanic plates, it gets embedded into softer asthenosphere of the continental plate, and as a result trenches are formed at the zone of subduction. We would be seeing detail about this convergent plate boundary in different aspects. Clear? If you could see, when it would be one oceanic plate, if we have development of one oceanic plate converging with one continent plate, then what generally happens is this oceanic plate obviously tends to subduct under that particular asthenosphere which is present beneath the continent. Hence we would be experiencing the subduction, and hence after subduction we would be experiencing melting of this particular crustal margin, and this melting will result into formation of volcanic mountains. And because of the applied compressional force, there are chances that we may have development of fold mountains as well. The best example for this oceanic collision and continental collision is all along the belt of North American western coast and South American western coast, where the Pacific plate subducting under this particular North American and South American coast will result into all along the fold mountain formation and the volcanic activity over there. Done. So if you see near the convergent edge, as I have said, as the crust is moving inner, the part of crust is destroyed. Hence the name which we give to this convergent edge is destructive edge. So as I have already mentioned, the subducted material gets heated up and is thrown out, forming volcanic island arc and continental arc systems, and it is a dynamic equilibrium which is achieved. So we will see deeper into this context of convergent. Why? Because many questions have been framed in UPSC mains examination on this basis. I'll go deeper into it in the upcoming slides. Clear? So let's complete this transform plate boundary once, then we will start up again with the convergent plate boundary. See, transform plate boundaries are simple. They are not constructive, not destructive. They just modify that particular landform. As I have said, in the transform plate boundaries, the plate boundaries which are present, they are parallel to each other and they move in opposite direction. So these kind of plate boundaries which would be developed wherever they might be developed, that is called as transform plate boundary. If you see in this particular transform plate boundary, two plates slide past against each other and there is no creation or destruction of landform, but there would be only modification of existing landform which is present. So if you see in oceans, transform faults are the planes of separation generally perpendicular to the mid-oceanic ridges. The best example which I can quote along the transform plate boundary is the San Andreas fault which is present all in and around the Californian region. So where the North American plate slides down the Pacific plate, resulting into formation of a transform fault development. That is the best example which is the resultant of the transform boundary moments. But this transform boundary moment is not that important because it is not constructing or not destructing. Chances are least that questions would be coming from this particular transform boundaries. Clear? So this is what generally happens. Like whenever we have divergent moments, then mid-oceanic ridges, and this divergent plate has to move and come under collision with some other continental crust and it has to subduct, however, and this subducting plate however melts and it tends to create volcanic eruptions all along the zones. Clear? And if you see, when two oceanic plates come in collision with each other, it is one oceanic plate which has to subduct, and which oceanic plate subducts, which one is denser, that would be subducting. And why oceanic crust is subducting under continental crust? Because yesterday I have given you a statement. The statement was like, oceanic crust is thinner and oceanic crust is denser when compared to that of continental crust. Hence it is the oceanic crust which subducts under the continental crust. And when two oceanic crust come into picture, which one should subduct? Which one is heavier, which one is larger? That generally subducts. Clear? So we will go deeper into this convergent plate boundaries. Because new crust is forming. Suryavardhan, they are building fold mountains on the coast. Clear? Is this clear for everyone? Shall we move further? So please give a like symbol, and also please do share the video for me. It would be an added motivation. If I get more number of views on these particular lectures, I'll get motivated and I'll come up with all such kind of important lectures for you on this particular platform called as Let's Crack UPSC CSE English. And also please do subscribe to Unacademy and don't forget to use the code called as VK10 to get the 10% discount. Clear? The 20,000 special classes on the situation of lockdown which is running in the country in the month of April and March, and it has been already started and initiated. You can just install Unacademy learning app and you can also learn various lectures, and Unacademy is a source for 30 major examinations in India. Clear? You can just imagine, it is the largest learning platform of India. Just try to download the app and you can watch the special classes over there. And if you want to get the subscription of the Unacademy for the continuous preparation of UPSC, please try to use my code called as VK10 so that you would be getting 10% discount. And on Unacademy platform, 100% entire syllabus would be covered. Thalari Srinivas, sir, Eastern Ghats and Western Ghats are formed by oceanic continental crust. No, absolutely false. They have some other origin. We'll discuss that in Indian geography. Mubina, sir, the movement of Indian landmass from south to north hemisphere is transform boundary. No, absolutely false. It is not transform boundary. Thalari Srinivas, its collision. Repeat the doubt, Srinivas. Clear? So, what are the evidences which we can give in evidence with the plate tectonics theory? Like, what are the evidences which we can show? One evidence which we can show is paleomagnetism. As I have said, like one of our aspirants have asked this question, what actually paleomagnetism is. Simply, if we have seen the earlier picture, just open the image of paleomagnetism once, you will get. Generally what happens is, when a ridge would be having development, see, for example, if this is a plate continuously and we had continuous development of ridge like structures, beneath this we have ascending air column, and see now the rocks which would be spread, which spreads away from the central zone, these rocks would be having a continuous line of strip in one sequential manner. Like for example, if north pole is in this direction and if south pole is here, so they will adjust accordingly. The northern pole, see these particular rocks, as they are rich in iron, they will also have some magnetic properties, and in that similar way they will adjust according to the north magnetic pole and south magnetic pole. And when the next chain of ridge would be formed, it takes some millions of years. And when such kind of next chain of ridge would be formed, when it takes millions of years, back then when next ridge would be formed, do you really think that the magnetic north and magnetic south would be at the same zone? No. Obviously it would change. It may differ or it may completely reverse. The magnetic north may reach to south and magnetic south may reach to north. Then what happened? The strip of rocks which would be extended from this particular central zone, that will attain one particular configuration, that will have the movement towards one particular line, like they might have the movement towards this northern pole. So in this way, the irregular strips which you can observe on the both side of ridges, that will give an evidence that as the magnetic field is not permanent, that will give an evidence that the seafloor is continuously spreading. In that regard, this paleomagnetism will also help us in understanding about plate tectonics theory. How? As the rocks, when they tend to adjust themselves according to the magnetic poles, this land masses, this crustal surface which is made up of rocks, that tend to move accordingly, and one that tend to move accordingly, we would be having the movement of plates. Hence paleomagnetism becomes one of the most important evidences in consideration with seafloor spreading and plate tectonics theory. And next evidence is older rocks from continents and younger rocks form oceanic floor. This is also one important evidence, like how the plate tectonics theory would be formed. Clear? Because of the subduction which happens, and gravitational anomalies, and the earthquakes and volcanoes which generally happen. We'll be discussing detail about earthquakes and volcanoes in the upcoming lectures, but as of now, just remember that it is just an evidence for the plate tectonics theory. So what is the significance of plate tectonics theory? Almost all major landforms formed on the earth's surface are due to plate tectonics. So whenever you write any answer related with plate tectonics theory, please try to write the significance as well. Please try to write the significance. Clear? And new minerals are thrown up from the core with the magmatic eruptions, and economically valuable minerals like copper, uranium are found near the plate boundaries. It is highly important. From present knowledge of crust plate movement, the shape of land masses in future can be predicted, but generally we can't predict. It is geomorphologists who can predict. The actual geomorphologist who every time do the research work on this, they can predict actually what's the crustal plate movement. And for instance, if the present trend continues, North and South America will separate, and a piece of land will separate from the east coast of Africa. Australia will move closer to that of Asia. And however, we won't be present to watch those things because it takes some millions of years. We may have this instance if the present trend continues the same. So we might see some of the major geomorphological modifications. Clear? So we will go deeper into plate tectonics. It's not like until now I have given the overview. Now we will see collision of oceanic plates and or oceanic convergence, collision of continent oceanic, collision of continent, collision of continent and arc or continent arc convergence. So we will be continuing up with this convergent plate boundary. So clear. So do you have any doubts related with this? Shall we continue? Is there any disturbance? Clear. So out of all the plate boundaries, it is convergent plate boundary which is the most important one. Clear. So in convergent plate boundary, we can derive three major convergent plate boundaries. One is continent oceanic convergence, that is oceanic plate coming in collision with continent plate, and oceanic plate convergence, and continent plate convergence. So these are the three plate boundary movements with which now you will have huge answers, like many answers which you could not found, you will be understanding with that. So first we will start up with oceanic convergence. Clear? So the concept of oceanic convergence helps us understand the formation of Japan group of islands, Indonesia group of islands, Philippine group of islands, and also Caribbean group of islands. And UPSC has asked this question already. Explain the formation of Indonesia and Philippines. Explain the formation of thousands of islands in Indonesian archipelago and Philippines archipelago. So what is archipelago? It is nothing but extensive group of islands. What is an island arc? Island arc is nothing but narrow chain of islands which are volcanic in origin. An island arc is usually curved structure. When you see the Japan group of islands, they appear like island arc structures. So in general, when two oceanic plates come and collide with each other, denser oceanic plate subducts below a less denser oceanic plate, forming a trench along the boundary of that subduction. Like Pacific plate coming in collision with Philippines plate, so obviously it is Pacific plate which would be subducting under. The larger the plate, the heavier the plate, the denser the plate would be. Hence the denser plate subducts every time. And whenever it subducts near to that subduction zone, we would be having formation of trench. You can watch this. Clear? This particular oceanic plate is subducting under this particular oceanic plate. And here at the zone of subduction, we would be having development of trench. Marine trench, which is the best example of all the trenches which is present in the Pacific Ocean, which has been formed because of the Pacific Ocean collision with the Philippines plate. We had formation of this particular marine trench. Clear? So what are the things which you can observe when oceanic plate is coming into picture? That would be the most important thing. So first point is a trench. Sorry, here इसको क्या हुआ? So first point is trench would be developed. Point number one. Second point is subduction happens and this portion would be melted. and the portion which is melting off, that tends to come out onto the opposite slab. And when it tends to come out onto the opposite slab, we would be having volcanic eruption in this zone. And the second thing which you can observe is volcanic eruption. Just give me 1 minute. इसको ये पेन को कुछ हुआ यार. Done. Clear? So like first thing which would be formed, that is trench. Second is volcanic eruption which you can observe. So this particular volcanic eruption which is present, can you comment, is it andesitic or basaltic? Can anyone comment, is it andesitic or basaltic? So it is andesitic eruption. So wherever we have divergent plate boundaries, in those regions we would be experiencing basaltic eruption. And in those regions wherever we would be experiencing subduction zones or convergent plate boundaries, there we would be experiencing andesitic eruption. Please do remember this, andesitic eruption. And this andesitic eruption is violent in nature, is very explosive, and the magma which tends to come out from this andesitic eruption is acidic lava. Clear? So andesitic eruption which is present, that particular andesitic eruption is having acidic lava associated with that. It is violent in nature, and as it is violent in nature, it is very explosive, and the lava which tends to come out, that is acidic lava. And acidic lava is that kind of lava which has maximum silica content associated with that. And as it has maximum silica content, it has less fluidity. And because of the less fluidity which is associated with this particular boundary, we would be experiencing formation of huge volcanic composite cones on the oceanic floor. So the subducted plate doesn't have the volcanic eruption. The volcanic eruption happens upon the opposite floor, and that volcanic eruption is andesitic in nature, which results into outcome of acidic lava that results into formation of huge composite cones. And due to the continuous volcanic eruptions of such kind, due to the continuous accumulation of magma, these volcanic composite cone like structures or volcanic feature like structures which are developed, they sometimes tend to come out of the oceanic floor, and that results into formation of island arcs. They are island archipelagos. Got this point? That result into formation of islands, and in such regard we had formation of Japan, Indonesia, Philippines, all these group of islands when Pacific plate was subducted under these particular oceanic plates. So as the oceanic floor crust loaded with sediment subducts with the softer asthenosphere, the rocks in the subduction zone becomes metamorphized and under high pressure and temperature, and after reaching a depth of about 100 km, the plate generally melts into the magma, and this particular metamorphized sediments and the melted part of subducting plate has lower density, and it raises upwards onto the next slab under the buoyant force offered by the surrounding denser medium. So the magma flows out to the surface. As I have said, a continuous upward movement of magma creates constant volcanic eruptions at the opposite oceanic floor, and constant volcanism above the subduction zone creates layers of rocks. As this process continues for millions of years, a volcanic landform is created, which in some case rises above the oceanic waters. And when it rises above the oceanic water, it results into formation of island. Such volcanic landforms all along the boundary form a chain of volcanic islands, which are collectively called as island arcs. They generally have arcuate structures, but it is not compulsion. So the Indonesian island archipelagos or Philippine archipelagos, Japan group of islands, they are the best examples of these island arcs. If you see the formation of Philippine island, so seeing this deeper is also highly important for you. So Philippine island arc system is formed due to subduction of Philippines plate under the Sunda plate. Please do remember this. Until now, you have thought that it was Pacific plate which has come into picture. But Sunda plate, it is major continental shelf of Eurasian plate. So, it is the Philippines island arc system which was formed under the subduction which was created by the Pacific Philippines sea plate under the Sunda plate. Please do remember this Sunda plate. That's the reason why I have asked you to remember about the minor plates as well. Sunda plate, it is nothing but it is the major continental shelf of the Eurasian plate. Hence the trench formed at this zone, it is called as Philippines Trench. Done. And the Sunda shelf which is present, the extreme southeastern portion of Eurasian plate which is part of Southeast Asia, which it is a continental shelf which is nothing but Sunda shelf, under which the Philippines plate has subducted and resulted into formation of Philippines island group. This region is called as Sunda shelf, and Sunda shelf and its island is known as Sundaland block of Eurasian plate as well. So whenever you write about Philippines formation, please try to write about this Sunda plate. Clear? So many people, they will directly skip this and they will directly write it as like Eurasian plate has come under the Philippine plate and we had formation of this Philippine islands. That is not enough for UPSC. 100% you have to write and have a specific mention on Sunda plate as well. Please try to remember this. Clear? If you could see, like, see the Philippines sea plate, it is coming under this blockade zone, and hence we had development of Philippine group of islands in this section. Do remember this. Please try to remember the Sunda plate. You can see exactly here the Philippines plate, and this is the Sunda plate, and it is the Sunda plate coming in collision with that of Philippines plate. We are having resultant of this particular Philippine group of islands. Clear? Is this clear for everyone? And Govinda Reddy sir, why archipelagos always curved shaped? It depends. Always they are not in curved shape. It depends. Ravi Teja sir, can we say volcanism is due to convectional cell? Volcanism is due to convectional cell, it's true. And volcanism is also due to subduction. It is also true. Now let's see formation of Indonesia. So whenever Philippines plate comes into picture, try to remember about Philippines plate and Sunda plate. And whenever this Indonesia comes into picture, the Indonesian archipelago has connection with Indo-Australian plate, subducting below the Sunda plate. Sunda plate is part of Eurasian plate. So Indonesia and Philippines archipelago, they have a huge connection with this particular Sunda plate. The trench which is formed at the boundary zone of Indo-Australian plate and Sunda plate, the trench is called as Sunda Trench. And the Java Trench is major section of Sunda Trench itself. So Anak Krakatau, the child of Krakatau volcano, lies close to this Java Trench. Please do remember this geographical location, which is situated in the Sunda Strait between the Indonesian islands of Java and Sumatra. Underwater land shifting of Anak Krakatau volcano in December 2018 triggered a tsunami that has killed more than 400 people in and around this Indonesian region as well. So this Indonesian group of islands, they are formed because of Indo-Australian plate which is subducting under the Sunda plate. Clear? You can see this particular picture. This is the Indo-Australian plate and this is the Sunda plate. So here Indo-Australian plate is subducting under and we had formation of Indonesian group of islands. Now the formation of Japan. Until now this question was not asked on Japan. They have asked it on Indonesia and they have asked it on Philippines, and not surprisingly many aspirants, they have written about the Pacific plate in that particular answer where Indonesia and Philippines have come into picture. Many people have gone wrong in that particular aspect. Clear? So no one has mentioned about Sunda plate or Indo-Australian plate or Philippines plate. Directly they have mentioned about the Pacific plate which is coming under the Eurasian plate, we had resulted into formation of the volcanic islands. Clear? But such kind of overview answers will never gain marks in UPSC. You have to focus on key points, key terminologies, so that you can 100% help. Clear? Japan, until now, no question has been asked. There are chances that questions might be formed in near future as well. If you see, Japan volcanoes are part of three volcano arcs. If you see, the Japan has been formed at the trijunction of collision of Philippines plate, Eurasian plate from one side, Philippines plate from other side, and Pacific plate from this side. So at this triangular junction of Philippines plate, Pacific plate and Eurasian plate, we had development of this Japan group of islands. So see, you can see this particular junction. This is the Asian plate and this is Philippines plate, and at this collision boundary we had formation of this particular Japan. So whenever you write about the formation of Japan group of islands, please try to mention about Pacific plate, Philippines plate and as well as Eurasian plate. The arcs meet at a triple junction on an island called as Honshu. You have to mention these particular key points 100%. The northern arc is formed due to subduction of Pacific plate under the Eurasian plate. The trench formed here is Japan trench, and the central arc which is formed due to the subduction of Pacific plate under the Philippines plate. You can see the trench is Izu trench. Clear? No need to remember about these trenches, but at least remember about this trijunction. Clear? This is highly important. So if you see, the southern arc is formed due to subduction of Philippines plate under the Eurasian plate, and the trench which is formed, it is Ryukyu trench. If you could remember and write, that would be best, but my suggestion is you can't remember them 100%. I can guarantee you, like, you would be having huge amount of confusion. Rather than writing confused answers, better write a crystal clear answer where an examiner can very well understand this. Clear? So Japan island arc was very close to that of mainland island, and the force exerted by the Pacific plate and the Philippines plate tilted the arc towards its east, giving rise to Sea of Japan. You can see here in this junction you would be having the Sea of Japan. Done. So now, marine trench, the most awaited concept. As I've already said, when two oceanic plates come into picture, we would be having development of this marine trench. Done. So marine trench or Marianas Trench, the deepest trench in the world, is located in the Western Pacific Ocean, and it is formed because of the subduction of Pacific plate below the marine plate. Marine plate is nothing but the subboundary of Philippines plate itself. If in option, if you won't find this marine plate, directly mark it as Philippines plate. And the maximum known depth is somewhere around 11,000 meters in its floor, known as Challenger Deep. You can see this question. I have quoted one expected question soon also. When volcanism happens, Suryavardhan, when volcanism happens, he has asked a question like how volcanism generates tsunami. Whenever we would be having volcanism, it triggers earthquakes, and that earthquake will be resulted into results into displacement of crustal boundaries, and that triggers tsunami. Akash Chaurasia, from where we can get PDF of this class? From subscribing the Unacademy platform. Sir, is volcanism and seafloor spreading are same? Because of volcanism, seafloor spreading is happening. Raviteja. Divya Darshini. Basaltic. I did not get you, ma'am. So this was already asked 2014 mains question. Explain the formation of thousands of islands in Indonesia and Philippines archipelagos. So whenever you write about Indonesia, try to mention, whenever you write about Philippines, try to mention about the Sunda plate. Don't exactly write about the Pacific plate, and don't say that this is the exact figure what we have read about. That is absolutely wrong. And expected question, and please try to write an answer related with that. So in spite of extensive volcanism, there is no island formation along the divergent boundary. Why? What is the reason associated with that? Please write a 100-word answer related with this particular question. Next, we will move into continent oceanic convergence. So, out of continent oceanic convergence, it is the oceanic boundary which subducts under the continent plate. Simply, why? Because the oceanic plate is denser when compared to that of continental plate. So, if you see the concept of continent oceanic convergence is important to understand about the formation of Rockies in the North America, Andes in South America, and other similar fold mountain systems across the world. So, continent oceanic convergence is similar to oceanic convergence itself. But one important difference is that continent oceanic convergence mountains are formed instead of islandic groups. So, when oceanic and continental plate collides or converges, the oceanic plate subducts or plunges below the continental plate and forming a trench along the boundary. This is 100% true. The trenches formed here are not as deep as those formed in the oceanic convergence. Here, a question might be framed in preliminary examination. Consider the following statements about trenches. Trenches are framed at the convergent and divergent boundaries. Option B. Trenches which are formed at the continent oceanic boundaries, they are deeper when compared to that of those trenches which are formed at the oceanic convergence. So both the options would be false. So do remember, the trenches which would be formed at the oceanic collision, those trenches are deeper when compared to that of those trenches which are formed at the boundary zone of continent and oceanic convergence. You can see, whenever we would be having continent and oceanic convergence, obviously it is true that the oceanic crust would be subducting under. So this particular oceanic crust which would be subducting under, that will result into formation of a trench zone. This is the first thing which would be developed. Then the portion which has been subducted, that would be melted, and this melted portion tends to come out onto the continental crust. Maximum times it doesn't come out, but when it comes out, it would be andesitic eruption again. Because of convergent plate boundary, we experience andesitic eruption. The same thing was happening in oceanic boundary as well, where there we were having development of island groups, but here we would be having development of huge volcanic composite cones. So along with this, we will also have the applied compressional force. It means the continental crust would also be folded. And second thing which you would be having the generation of is volcanic mountains. And the third thing which you would be having development, it is the fold mountain system which would be developed. So you can see all along the western coast of North America, all along the western coast of South America, you will be having development of Rockies, you will be having development of Andes as well. Clear? So please try to remember this. If you see, like, what are the consequences which would be formed? One is continental arcs, one is fold mountains which would be formed. If you see formation of Andes in South America, they are formed due to convergence between the Nazca plate. Make a star mark over here. They are formed due to Nazca plate convergence and South American plate convergence. Clear? The Peru-Chile trench, which is present at the subduction zone of the Nazca plate, is the best living example as the collision which happens here. And if you see and these are continental arcs. What are continental arcs? Continental arcs are nothing but they are narrow band of mountain systems which are volcanic chain, which are formed due to volcanism above the subduction zone. These kind of structures, wherever they would be developed, they are called as continental arcs. All along the Andes and all along the Rockies, we would be finding such kind of continental arcs. So the pressure offered by the accretionary wedge folded the volcanic mountain, raising the mountain significantly. Clear? What is accretionary wedge? No need to remember that, but still I'll quote an example over here. See, when the oceanic crust is subducting at the trench, those unnecessary extra landforms which are present on the oceanic crust, which might have been formed earlier, those particular aspects would be peeled off from that oceanic crust before the subduction, and that peeled off material would be accumulated onto the continental shelf margins, and they come out onto the oceanic floor and they will enter into the continental crust as well. These scrapped off material which accumulates on the opposite slab of subduction, that is called as accretionary wedge, or sometimes it also would be referred as accretionary prism as well. Clear? So in this zone of Andes, volcanism is still active. Apart from this, because of continuous movement of South American plate, we have continuous folding process, and the mountains in and around these Andes are continuously rising. So if you see Ojas del Salado, I don't think so that it is Salado, Setado, I hope. Ojas del Salado, which is active volcano on the Argentina-Chile border, is highest active volcano on the earth. Like it comprises of somewhere around 6893 meters. Done. And Mount Aconcagua, which is present in Argentina region in the Andes, is the highest peak outside the Himalayas and is highest peak in the Western Hemisphere. And it is an extinct volcano which you have. Next, if you see formation of Rockies, what was the plate involved in formation of Andes? Please do comment. People who are live, please do comment. What are the plates which were involved in the formation of Andes? Yes, people who are live, please, you have to comment 100%. You have to be very active, despite it has been your sleeping time. So, like, you have to sacrifice some things. Please. Srinivas, I'll get back to you. Clear. So if you see, the similar pattern repeats with Rockies. But in Rockies, the plates are different. North American plate moved westward, while the Juan de Fuca plate, please do remember this plate. While I was discussing about the minor plates, I had a mention of this particular Juan de Fuca plate and the Pacific plate as well. The Juan de Fuca plate and the Pacific plate coming under the collision of this North American plate will result into formation of Rockies. Similar pattern as that of Andes. This convergence gave rise to series of parallel mountain ranges. Unlike the Andes, Rockies are formed at a distance from the continental margin. If you see all the Rocky mountain ranges, they were somewhat far away of coastal region. Clear? So due to less steep subduction by the oceanic plates, we had formation of Rockies somewhat far away from the coast. So the trench which happens here is less conspicuous as the boundary is filled with accretionary wedge completely. So the trenches which are present in this zone, they are completely filled up this accretionary wedge. Hence the availability of trenches in these margins are very least. And in this zone itself, we have the notion of San Andreas fault. And you can see this particular region coming under the subduction zone will result into formation of cascades. Cascades are nothing but group of mountain ranges. If you see in the North America, apart from Rockies, you will also see some of the major coastal mountain ranges like Cascade Range, Sierra Nevada Range, Coast Range. So you will find many other mountain ranges apart from Rockies. Done. So these combination of different mountain ranges apart from this continental arcs, they are called as cascades which are associated with that. Clear? Now the next collision which is very much important for you. So it is continental collision. In oceanic convergence and continent oceanic convergence, at least one of the plates is denser, hence the subduction zone is quite deep. But in continent collision, no plate has subduction. So in continent collision, we won't experience any kind of subduction at these margins. So due to the lower density, both of the continental crustal plates are too light and to be carried downward into the trench. In most of the cases, neither plate subducts, or even if one of the plates subducts, the subduction will not go deeper than 40 to 50 kilometers. So is my voice clear, everyone? So is my voice clear? If so, please do drop in the comment section. We'll move further. Nazaka plate, it's true. Absolutely true. Clear. See, In continental collision, maximum number of times neither the plate subducts. If it is subducting, then also it doesn't go beyond 40-50 kilometers. So these two plates converge, buckle up, fold, and faults would be created. The best examples are Himalayas, which would be generated. The Indian plate moving northernward, colliding with the Eurasian plate, has resulted into formation of huge fold mountain system. And Himalayas, if you see, they are formed with the collision of Indian plate colliding with Eurasian plate. They are the youngest fold mountain chain of the world. Himalayan mountains have come out of great geosyncline called as Tetici, and that the uplift has taken place in different phases. That's why we had formation of different three range of mountain ranges called as Himadri, Himachal, and Shivaliks. We'll be discussing about Himalayas during the marathon sessions of Indian geography. Clear? So if you see, its northern part consisted of present day North America and Eurasia, which is called as Laurasia or Angara land or Laurentian land. So I'll be discussing about these Himalayas later on. Like all these are associated with this particular continental drift theory itself. If you could see this image, the Indian plate colliding with that of Eurasian plate. So we had huge chain of folding of mountain structures. So this huge chain of folding of mountain structures are nothing but the Himalayas. So we can generally observe huge amount of fold mountain sections. Apart from that, we can observe the earthquake zones. Clear? These continental zones, wherever we might see, in those regions we would be experiencing maximum amount of earthquake development. The reason behind it is that happens just because in these margins, as there would be no subduction or very least subduction, we would be having maximum compressional force which would be applied in this region. So like all the sediments were brought by the rivers and were deposited on the floor of Tetici. So everyone know about this Tetici, and this Tetici, when the Indian plate was coming towards the Eurasian plate, this Tetici have got narrowed, and this narrowed Tetici has accumulated the sediments, and those sediments have came out of this Tetici where we called it as geosyncline. And when Indian plate has hit the Eurasian plate, along with the crustal folding and the rock fragments, the sediments from this floor of Tetici, that is geosyncline, were also folded, resulting into formation of huge chain of fold mountain and loftiest peaks of the world. Clear? So volcanism and earthquakes in continent-continent collision. Like, do we experience volcanism? No, absolutely no. Why we won't experience volcanism? The reason behind it is, as we are not having any subduction, there would be no generation of newer magma. Hence, no magma tends to be created, and no magma tends to. That entire zone would be very much high associated with these particular earthquakes. Please do remember this. This particular continent convergence would be experiencing maximum earthquake zones around the world. So try to refer to this question once. Clear? So is this clear? Like, please try to frame an answer on this. Why the world's fold mountain systems are located all along the margins of continents, and bring out the association between global distribution of fold mountains and earthquakes and volcanoes. Clear? So please try to write an answer on this particular question. This was one of the question which was asked in UPSC already. That's why I have mentioned this particular question for you. So now let's see the mountain building process. Now you have understand about the plate tectonics theory, right? So now it would be very easy for you to understand about different mountain building process. So shall we move further? Do you have any doubts on this? So we have some different mountain ranges, and out of this we can calculate it as fold, block, volcanic, and circum-erosional or relicit or residual mountains. Clear? So first we will start our discussion with the fold mountains. How the fold mountains are formed? Either because of the collision boundaries which happen at oceanic continental collision and continent continental collision, we would be having development of fold mountains. And in the similar way, wherever we have divergent plate boundaries, block mountains develop, and wherever volcanic magma accumulates, volcanic mountains develop, and wherever the external factors would be having their higher rate of erosion, their circum-erosional or relicit or residual mountains would be available. Clear? So please try to like this video, and please try to share this video, which gives a motivation for me, and do subscribe to Let's Crack UPSC CSE English channel, and also please try to focus upon the subscription which is being done by Unacademy. Clear? So please get the subscription today itself. People who haven't installed the app of Unacademy learning app, please try to install that app. That is the most important thing which you have to do, like before you crack civil services, because just by sitting at your home, if you want to crack civil services, it happens only with Unacademy, which is largest learning platform of India. Now we will see about fold mountains. Any doubts, sir? Snake, what type of mountains are formed? What type of mountains are formed? Are they fold mountains? Repeat your doubt, Aniket. So Raviteja sir, in collision of Indian and Eurasian plate, which plate subducted? Indian plate. Clear? It is Indian plate which got subducted, Raviteja. Clear? So we'll see about fold mountains, right? Fold mountains are formed with sedimentary rock strata in geosynclines which are subjected to compressive forces. It means when two plates come in collision with each other, we would be having folding, either like if one plate is only coming into picture, and if compressional forces are applied on this one particular plate, we would be having folding of this plate. But when two plates come into picture, along with the folding of this crust, the central margin, if it has completely water, the sediments which are present on the floor of the water, they would be raised up, and this portion, when it is getting narrower, it would be called as geosyncline, and that geosynclinal folding will also happen when the fold mountain systems are present. Here, if you see, the fold mountains are loftiest mountains, and they are generally concentrated along the continental margins itself. And why they are generally concentrated on the continental margins? The reason behind it is, in the collision zone of subduction, or in the collision zone where compressional forces would be maximum, there only we would be having formation of the mountain ranges. Clear? And what actually is a geosyncline? It is a large scale depression in the earth crust containing very thick deposits. Example is Thetis geosyncline. Like, simply it is nothing but like if Indian plate is present in this way, and if this is Thetis completely, and when Indian plate is moving further towards the Eurasian plate, this Thetis would be getting up very narrower, and when this Thetis would be completely narrower, what generally happens is, this narrower portion, it appears like a valley or a depression like structure. That depression or a valley like structure would be called as a geosyncline. And if you see the fold in geology, like this is not necessary for you, but for your understanding I have given it. A fold is nothing but undulating structure that forms when rocks or part of the earth's crust is folded under compressional forces. Clear? And a fold would be having anticlines and synclines. The upward convex shape is called as anticline, and the downward core center area, it is called as syncline. Clear? So anticline and syncline areas. So if you see the downward convex portion, it would be called as syncline. If you could see here, you can observe the crust which got folded, the uppermost portion of the crust which got folded. So here you can see anticlines, here you can see synclines. So fold systems would be having development of anticlines and synclines in this way. Done. So, and we have many types of folds. Like it's not like fold should be exactly in this way. Fold might be in any other way, in this random way. Fold might be any other way. Fold might be steeper, fold might be flatter, fold might be in this way as well. Clear? So any type of folding may happen. In this way we have different types of folds. No need to remember this as well. So if the limbs of these folds which are present, if they are almost symmetrical, if they are almost equal, that would be called as symmetrical fold. And this kind of limbs, if they appear, they are called as asymmetrical fold. And if you see the isoclinal fold, like they have the limbs that are essentially parallel to each other. So, and you can see overturned fold in this way, like overturned. And recumbent fold, essential, they has an essentially horizontal axial plane, but not, don't remember this. I don't feel that questions would be coming from these sections. Clear? So classification, if you see of fold mountains, so in the recent one of the UPSC CA PF examinations, I have observed one of the question, like they have asked which of the following mountain ranges are part of very old fold mountains of the world. So such kind of questions are on and often asked in UPSC. So if you want to focus on those particular aspect, you have to 100% focus on this. If you see, on the basis of period of origin, fold mountains can be derived into very old, old and alpine fold mountains. And those fold mountains which fall under the category of very old fold mountains, they are those mountains which were formed 500 million years old. And these particular fold mountains, they have somewhat rounded features. Like if you see from the top, they would be having somewhat circular features. This circular feature has been developed just because of the process of denudation. And if you could see, these particular very old fold mountains of the world, they would be having very lower elevations. The reason behind it is it has been formed very long ago, and also it has come under huge amount of denudation process. So it might be in North America, which are located to the southeastern portion of North America, and the Ural Mountains, which divides Russia with Europe. Those Ural Mountains, they are the best examples of very old fold mountains. And if you see the next set, old fold mountains, old fold mountains had their origin before tertiary period. Like tertiary period just started 66 million years ago. So just before that we had formation of this old fold mountains. And if you could see the fold mountain systems which are present, Caledonian and Hercynian, which are present in North America and European regions, these mountain ranges are part of old fold mountains. Clear? And if you see, they are also called thickening relicite fold mountains because of lightly rounded features and medium elevation as well. So top layers are worn out due to erosional activities. Example, Aravalli ranges in India, they are also considered as one of the oldest fold mountains of the world. The Aravalli range in India is the oldest found mountain systems in India, and it is one of the old mountain systems in the world. Clear? The range which was created during post Precambrian event, it is called as Aravalli Delhi orogeny. Done. So next, alpine or young fold mountains, we have huge amount of connection with these. So everyone know about these, like those fold mountains which were formed, which belongs to the tertiary period, they can be grouped as new fold mountain category since they originated in tertiary period. Examples include Rocky Mountains, Andes, Alps, and Himalayas, and also do remember Great Dividing Range of Australia. All of these mountain ranges, they belong to one certain period, and all these mountain ranges, they are formed in one certain era. Hence, they are considered as alpine mountains or youngest fold mountains of the world. And if you see the characteristics of these young fold mountains, they would be having huge amount of rugged relief, huge amount of heights, loftiest peaks of the world are found, and also you would be finding high conical peaks. So these are the most important categories of this young fold mountains. So characteristics already have discussed, like it has greater lengths where their width is considerably small. They are youngest mountains, have sedimentary rocks associated with that. Is this clear for everyone? Any doubts on this? A Ravi has a doubt. When there is collision of continent and continent, is there any scope of subduction? Yes, it is. There is a scope of subduction. As I have mentioned, the scope of subduction is only up to very limited depth. Please do remember this point. The scope of subduction is only up to limited depth. Clear? So the next chain of mountains which are considered, they are block mountains. They are created because of the faulting on the large scale. Faulting is nothing but displacement of rock. Displacement of rock either vertically or horizontally, it would be called as the faulting process. Either the fault may happens horizontally or vertically or horizontally. Clear? So the uplifted blocks are termed as horst and the lower blocks are termed as grabens. I'll show in the upcoming figures what actually the horst and graben are. If you see, already I have discussed this, like when I discussed about the divergent plate boundary movement which happens on the continent, that will result into formation of rift valleys, and that rift valleys which would be developed, those rift valleys would be having block mountains associated with them. In such a way, the great African rift valleys adjacent to that, they have block mountains. The Rhine Valley of Europe and the Vosges mountains in Europe are the examples of block mountains. Clear? So block mountains are also called as fault block mountains, since they are formed due to faulting as a result of tensional and compressional forces. Just to do remember one statement, that faulting can happen because of tensional and compressional forces. So if we have tensional forces, we would be having normal faulting. Like when two blocks move away from each other, the central block tends to displace and we would be having normal faulting. But when on the cracked block, when two crusts have been broken, we would be having a fracture which would be developed. When we experience compressional force on that, there are chances that we would be experiencing reverse faulting. If you could see on this particular figure, we had the compressional, like divergent forces or the tensional forces which has applied, and because of the tensional forces which has applied, first initial stages we had development of crack, and post this initial stages, this particular central region has subsided down, and this particular subsided region which is present, this particular region, it is called as rift valley. And if this rift valley, clear, which is present, that instead is considered as graben. As I've said already, like this particular position where we have discussed about graben, this rift valley is considered as graben, and the adjacent regions have not raised, but because of the subsidence of the central block, the adjacent regions are being appeared like mountain ranges. Hence these ranges which are present in this zone, they are considered as block mountains. They are not true mountains as well, because there no real actual upliftment has happened. So block mountains are formed when cracks or faults occur in the earth crust and on the land between the crack sinks, leaving upstanding blocks on the either side, which would be called as block mountains. In India, Narmada and Satpura, earlier they were fold mountains, but now, as of now, they are block mountains, because in between them we had development of a rift valley. The Narmada and Satpuras, when they were created, clear, sorry, the Vindhyas and Satpuras, when they were created, they were fold mountain systems. But those fold mountain systems, they got eroded and flattened surfaces were remained. But when the rift valley was generated between these two mountain ranges, hence these two mountain ranges, that is Vindhyas and Satpuras, started appearing like block mountain chain system. Clear? So like if you see, when any block is moving downward, this is called as down thrown fault block, and this is up thrown fault block. And this down thrown fault block, when it subsides down, we will have the result of this particular resistant region, and when you stand here and when you watch them, they appear like block mountain. Clear? So like see, these are normal faults which generally happen. Clear? Normal faults are those when the down thrown block moves down. If you see, the subsided region here we are experiencing, this is normal faulting. So either because of normal faulting or because of reverse faulting we would be having block mountings. Clear? So due to the normal faulting we have development of rift valley which is called as graben, and the adjacent elevated region it is called as horst. So you can see this entire region would be considered as normal faulting region. Clear? So tilted block mountains have one steep side contrasted by a gentle slope on the other. Lifted block mountains have a flat top and extremely steep slopes. Clear? And everyone know about faulting. As I've said, it is nothing but the displacement which generally happens because of rock, either because of the geomorphic process which are like applied tensional forces. So all these comes under the faults region. Clear? So when cracks would be developed, faulting takes place. And if you want to define a fault, it is nothing but a planar fracture in the volume of earth crust across which there has been significant displacement of block. The fault edges are very steep. You can see in this figure. The fault edges, if you see, they are very steep in nature. So we won't find any kind of like gentle slopes along these fault planes. Clear? So we would be experiencing very steep. Example, the Vosges and Black Forest of Rhineland region in Germany, they are the best examples of the fault plains which have been developed. And as I've already mentioned, the faults, they would be occurred because of the tensional forces and as well as compressional forces. And large faults within the earth crust result from the action of plate tectonic such as subduction zone or transform faults, and energy release associated with rapid movement on the active fault is cause of most of the earthquakes. So in those regions where we would be having active fault zones, those regions would be considered as active earthquake zones as well. Like for example, if you see the Kutch region of Gujarat, where beneath it we have huge amount of fault associated with that. That's the reason why Gujarat, despite of being far away from the Himalayan section, we would be experiencing huge amount of earthquakes in that region. See, now you can see this is normal fault, like when we would be having displacement of rock down the slope, hence we would be having formation of block mountains, and this is rift valley. This is normal fault where this is considered as fault plane. And if you see, once if there is crack which is associated and after the develop pushed towards each other under the applied compressional forces, hence then what happens is this block, instead of moving inside down to the down into the crust, it moves upward towards the crust, resulting into formation of reverse faulting. So this is reverse faulting. So these normal fault and reverse fault, they are considered as dip slip faults. They are considered as dip slip faults. And if you could see this particular aspect, whereby the the block ranges, if they are not sliding vertically either downward or upward, if they are sliding away from each other, they are called as strike slip faults. So along the transform plate boundary movements, we would be experiencing this particular strike slip faults. So normal fault occurs mainly in the areas where the crust is being extended, such as divergent plate boundaries, and reverse fault occurs near the convergent plate boundaries. So Rift Valley system, like as I've already said, this Rift Valley system is having association with block mountains and divergent plate boundaries. So in general, the tensional forces causes the central portion to let down between two adjacent fault blocks, forming a graben or rift valley, which would be having steeper wall-like structures. The East African Rift Valley, which is associated, that is the best example. Please open your atlas and try to mark this particular East African Rift Valley, and try to see the lakes which are associated with this East African Rift Valley as well. Clear? So block mountains which are present, they have association with this Rift Valley system itself. Clear? And the next chain of mountain, clear, which is present, that is volcanic mountains. Like volcanic mountains are formed due to volcanic activity. Like if you can see, simply because of the Aconcagua, Mount Kilimanjaro, Mount Mauna Kea, and Mount Fujiyama are best examples of this. And this particular volcanic mountains, they include molten lava, volcanic bombs, cinders, ashes, dust, and liquid mud. This everyone knows, even a kid knows this, right? Yes, wherever we would be, yes, Talari Srinivas, wherever we would be having the formation, wherever we would be having collision, wherever we have subduction, you would be having trench formation. This is very simple example which you can take. Clear. So these particular, they, as I've said, these particular volcanic mountains are often called as mountains of accumulation. And if you could see, all along the circum-Pacific belt, in and around the Pacific ring of fire. So what is Pacific ring of fire? As this Pacific belt is every time under the huge volcanic activities, it would be considered as Pacific ring of fire. So what is a ridge-like structure? Ridge is nothing but what we have discussed during the mid-oceanic ridges. They refers to the mountain which originate as a result of local folding and faulting. That's it. And mountain range, what is mountain range? On and often you would be seeing this particular question. It refers to series of ridges which originate in the same age and underwent same process. If you see the example, the Himalayan system is a mountain range with Himadri Ridge, Himachal Ridge, and Shivalik Ridge. So this group of ridges, group of parallel mountain ranges, they would be referred as one particular mountain range. Clear? And mountain system, a group of all these form as mountain system. Clear? So mountain chain, like if you could see, all the mountain ranges which differ in size and period of formation but still are present. Clear? The entire region, if it is dominated with ridges, different ranges, different chains, different mountain systems, they are considered as mountain chains. So these are simple terms which you have to remember at least. So please try to locate all these mountain ranges. Please make a note of all this. Just 1 minute. Clear? So please try to make a list of all this. The longest mountain ranges, Andes, Rockies, and Himalayas, they extend right away from right away of 2,400 kilometers. Please try to mention all these longest mountain ranges. So Rocky Mountain ranges, how they are formed, everyone know. So if you see the North American plate when it was colliding with the Pacific plate and the Juan de Fuca plate, we had the formation of this Rocky Mountain ranges. If you see, in generally in many of the books, they are considered as Western Cordilleras as well. Sometimes it is referred as Western Cordilleras. Clear? So these Western Cordilleras entirely are the resultant of the movement of North American plate towards the Pacific plate and which is present in that particular region. So in North America, you would be having some important mountain ranges. Like if you see, they can be divided as American Cordilleras, which are divided as Northern Cordilleras. So the ranges from Cordillera from Mexico northwards are collectively called as North American Cordilleras, which includes Alaskan Range, Brooks Range, and main belt of Rocky Mountain along the parallel Columbia Mountains, and Sierra Nevada ranges, Cascade ranges, and various small Pacific coastal ranges. Please try to mark all of them in your atlas. Please highlight them in your atlas on the western portion of your North America. This will 100% help you. And if you see in Mexico, the Cordillera continues through the Sierra Madre Occidental and the Sierra Madre Oriental, but this doesn't, it is not visible over there, so don't try to focus on it, but try to focus on these particular ranges which are present at the central location. And the South Cordilleras, the Cordillera continues through the mountain ranges of Central America in Guatemala, Honduras, Nicaragua, Costa Rica, Panama, and becomes the Andes Mountains of South America. So Andes with their parallel chain continue to very tip of South America at Tierra del Fuego. So you can mark Andes and you can mark all the important mountain ranges of Andes. That is highly important over here, which you have to mark. And cascade range, like in the North America, it is most important. Like these ranges or cascades in general, wherever you see this word, it is a mountain range of Western North America. They are part of Pacific Ocean Ring of Fire itself. So simply, the volcanic eruption which generally has happened on the Pacific plate along the Pacific oceanic boundary, so those volcanic eruptions have resulted into formation of volcanic peaks. They are nothing but cascades. If you see, they are made up of band of thousands of very small short-lived volcanoes, and this cascade range is very important in the western portion of North America. Clear? So these volcanoes and earthquakes in the cascades rise from a common source, that is from the subduction, where the dense Juan de Fuca oceanic plate plunges beneath the North American plate. So when Juan de Fuca plate comes into picture with that of North American plate, we would be having development of this cascade range. You can see here in the North American location, these are the cascade volcanoes. Clear? And at the coast, you can see the Olympic mountains, which are called as coastal range. In the North American coast, you can observe this. And see, this is Juan de Fuca plate, which is coming under the collision, what's so called as cascade ranges. We would be having the Rocky Mountains. As I've already said, Rocky Mountains, which are the continental arcs and combination of fold mountains, they are far away from the coast. So Andes mountain ranges, they are the longest continental mountain range in the world. World highest mountain range outside Asia with an average height of 4,000 meter. Highest peak in this Andes is Mount Aconcagua. So world's highest volcanoes are in the Andes. If you see, Ojos del Salado on the Chile-Argentina border is the highest volcano on the Earth's surface itself. So you can see the Andes mountain ranges. You can see Ojos del. Clear? It is present in Australia. Is the most Australia's important mountain as Australian Alps, and it was formed due to rifting process. If you could see the development of Great Dividing Range due to the Rift Valley Association and the development, the Australian Alps has been formed. Hence we had generation of this Tasman Sea over there. So Aral Mountains, like as I've already said, they are located, you can see the Aral Mountains here. They are the very old fold mountains of the world. Aral Mountains along with the Appalachian Mountains. These mountain range runs approximately from north to south through western Russia, from the coast of Arctic Ocean to the Aral River and to the northwest portion of Kazakhstan. And these particular Aral Mountains are formed because of continent-continent collision of supercontinent called as Laurasia with the young and weak continent called as Kazakhstania. And their eastern boundary of Ural Mountains is usually considered as natural boundary between Europe and Asia, as I've already said. You can see these Aral Mountains over here. Please make a mark of this particular Aral Mountains in your atlas. Next, Atlas Mountains, they are located to the northwestern portion of Africa, and they are extended about 2,500 kilometers all through Algeria, Morocco and Tunisia regions. The highest peak is Toubkal, which is somewhere around 4,165 meters in the southwestern Morocco region. And Morocco is on and off in news. Try to see the geographical extension of Morocco. Is it having any connection with Mediterranean Sea or not? Is Tunisia having any connection with Mediterranean Sea or not? Please try to visualize these particular things whenever you remember about these Atlas Mountains. And if you see these Atlas Mountains, they are formed when Africa and Europe have collided. So during that section, we had formation of this particular Atlas fold mountains. If you could see, this is the location. See, this is the location of Atlas Mountains. Done. And you can see the Great African Rift Valley. And this Red Sea presumes to be appeared like the part of Rift Valley itself. Next, Himalayas, as everyone knows, they are the largest Himalayan ranges home to planet of highest peaks, including Mount Everest as well. So if you could see like about the Himalayas, I'll have a deep discussion in Indian geography, don't worry. And Alps, everyone know, they are formed as the African and Eurasian tectonic plates when they are collided. They are extended all along the southern European region. They are the most important ranges of Europe. Clear? So this is up with this particular mountainous chains. And if you have any doubts, please you can drop in the live chat session. Sir, Raviteja has asked a doubt like, sir, is all mountains are formed due to continent collision and oceanic continent collision? That is what I have said. Like, mountains differs in types. Mountains, if they are fold, they either might have been formed because of continent collision or continent oceanic collision. If mountains are block, they are formed at the divergent plate boundaries. If the mountains are volcanic in nature, they might have been formed because of the continental oceanic collision and oceanic collision. And if the mountains are residual or dissected, those not only because of continent collision and oceanic continent collision, because of which the mountain ranges are formed, we have many other reasons. That is what we were discussing in this. Clear? So if you have any doubts, please let me know, and please do drop comments beneath this particular video so that everyone can attach to this video very perfectly. And please do share this particular video on your social platforms, as this particular video on the during this lockdown session may reach every corner of the country, so that people would be getting benefited from these particular videos. Clear? So if you have any doubts, I'll wait for 1 to 2 minutes. You can drop them in the live chat session. And also, do remember, don't forget to subscribe to Let's Crack UPSC CSE English channel, and please click on the bell icon so to get continuous notifications. Clear? To get the continuous notifications, please click on the bell icon which is visible, and please do subscribe to Unacademy channel so that you can get benefit. And before getting the subscription of Unacademy, use the code called as VK10. So use this code called as use this code called as VK10 so that you would be getting 10% discount on the platform. Please try to use this code called as VK10 before you get the subscription done, and please give a like symbol so that it will be 100% motivating me to come better and better for you for the next lectures. And I'll be taking up such kind of lectures only when more amount of views are present on this particular video. So for maximum views, please try to share this video as much as you can. Clear? If I have maximum views, I can continue up with such kind of sessions on this Let's Crack UPSC CSE English channel. And don't forget to use the code called as VK10 before you get the subscription of Unacademy. Please share this video. Please give a like symbol. All are ready. Thank you, Raviteja. Everyone, thank you everyone for staying with me until this late night. Hope you already had your dinner. Stay home, stay safe. Don't like go beyond the rules. Like, lockdown regulations are very strict in nature, so try to stay with Unacademy, prepare with Unacademy. You can crack whatever you want. You can crack UPSC CSE very easily with India's largest learning platform. As like me, the total team of 100 educators are present on Unacademy platform who will make your brains very sharper to crack civil services. Thank you everyone. Hope you don't have any doubts on this. Thank you for watching this video. Have an awesome day. Jai Hind.